So today's lesson in our unit Mix and Flow of Matter, our lesson today is density. This is topic 5. So when we talk about density, we are talking about the mass per unit volume of a substance. So you can think about it as the crowdedness of the particles that make up matter. So each substance is going to have its own unique density. That means water will have its own unique density. Gold will have its own unique density. Aluminum will have its own unique density. So all substances have its own unique density based on how close the particles are. So here in this example, we're looking at this here has a high density. Look at how close the particles are together. And here we have low density. So we can see there's a lot more space between the particles. Both objects, however, are the same. They are equal in volume. So this is the same sized cube, but they are different in mass because of their density. So density of solids, liquids, gases. If the density of a substance is greater than the density of a fluid, the substance will sink. So think of something like something metal that you put into water. It will sink because the density of that metal was greater than the density of the water. If the density of a substance is less than the density of a fluid, the substance will float. Some solids are even less dense than some liquids. So think about wood. Wood can float on water, even though it's a solid. Liquids cannot support objects the way solids can because of the particles. The particles of a liquid, they move apart easily, allowing a dense solid object to pass through the liquid. And then gases are even less dense than solids or liquids. So think about when you're moving through the air, you are moving through mostly empty space, but think of that now when you're running through water. So let's say you're at the swimming pool and you're trying to run through water. It's much harder to run through water than it is through air. So this is just a comparison of that. Running through air is much easier and faster than running through water. And in general, we know that gases are less dense than liquids. Here, so although liquid particles are sometimes quite closely packed together, they cannot support objects the same way that solids can. And the reason being is that liquid particles are able to move apart easily because the particles, they don't have a strong enough attraction to each other. All right, and then here in this diagram, when you're moving through air, you're not having to move away as many particles as you would if you were in water. So continuing with density of solids, liquids, and gases, when an object moves through a fluid, the particles are pushed apart and the object is able to move between them. Particles in a solid cannot be pushed apart because those attractive forces between the particles are much stronger than between fluid particles. As temperature increases, a substance we know can change from a solid to a liquid to a gas. So particles, they're spreading out as they gain energy when heated. Particles will take up more space and therefore density decreases. Most pure substances, the solid state has a greater density than its liquid state. The solid and liquid state are denser than the gaseous state. The exception is water. When we take ice, the ice is actually able to float on water. And we'll see a quick video on why that is. So let's take a look here. Next, we are looking at a density tower. So this is what can be done with different materials to show all the different phases in a density tower. So if we look here, this here, it says die, but it's a it would be dice, I believe. There's a dice in there. So look at all the different liquids. On the left-hand side, we've got honey at the very bottom, so therefore it's the most dense. Milk, water, we've got oil, and then a lamp oil here. Then we've got some other materials here on the right-hand side. The metal bolt here, would be the most dense at the bottom there. All right, so changing density by changing concentration. So like we said, density depends on the number and kind of particles in a given volume. But what would happen if you, for example, added salt to water, right? So dissolving salt into water will increase the number of particles in that given volume. So by adding more particles, you're now increasing the density of the water solution. So denser objects will float in the salt water than it does in distilled water. So comparing the two densities, distilled water has a density of 1 gram per milliliter, and seawater has a density of 1.03 grams per milliliter. And the Dead Sea in Israel has a density of 1.23 grams per milliliter, which is why you can actually float in it. All right, so when we talk about density, we're talking about mass and volume. So how is the mass and volume related? So how can we measure density? So firstly, we need to know its mass. Mass is the amount of matter in a substance. You can measure mass by simply using a balance to measure the mass, a balance or a scale. Next is volume. Volume depends if it's a liquid or if it's a solid. If it's a solid, if it's like a cube shape, or if it's a rectangular prism, we can calculate volume by length times width times height. If it's not an irregular shaped object, you can find the volume by measuring the volume of the water that spills out of an overflow can. It was called Archimedes' principle. If we have a liquid, it's easily measurable. You can put it into a measuring cup or a graduated cylinder and just note its volume in milliliters or liters. Volume of a gas can be measured by the volume of the container that holds it. Keep in mind when we talk about capacity, that's the greatest amount of fluid that a container can hold. So density, therefore, is a mass to volume ratio. All right, so again, mass is not the same as weight. So mass is the amount of matter in a substance. Weight is the force of gravity exerted on an object. Mass is measured in like kilograms or grams. Weight is measured in newtons, capital N, because it depends on the force of gravity exerted on an object. So a force is a push or pull that causes a change in the motion of an object, and gravity is that natural force that causes an object to move towards center of Earth. And on Earth, gravity is pulling downwards with about 9.8 newtons for every kilogram of mass. So for example, if we talk about a bag of sugar, it has a mass of 2.26 kilograms, but it weighs 22.1 newtons on Earth. So you just take 2.26 kilograms, you multiply it by that 9.8 newtons. All right, so this is our formula for density. So density is equal to mass over volume, or mass divided by volume. And your density, therefore, if we're looking at a solid, it would be grams per centimeters cubed. If we're looking at a liquid, it will be grams per liter or grams per milliliter. All right, so that's the difference if it's a solid or a liquid. So let's take a look at this first example here. What is the density of an object having a mass of 10 grams and a volume of 2 centimeters cubed? So we're going to use our formula. Density is equal to mass divided by volume. Our mass is 10 grams. Our volume is 2 centimeters cubed. We divide that and we get our density of 5 grams per centimeters cubed. Okay, so using our formula, we know that density, right, is equal to mass over volume. So when we're putting this into our formula, our mass was 10 grams, like this. And since it's a solid, our volume is 2 centimeters cubed, like that. So 10 divided by 2, that gives me 5. and make sure we use the correct units. It's grams per centimeters cubed. Okay, so here is a method to remember the formula because you will be given questions where you're trying to calculate density, and density is mass divided by volume. But let's say you had to calculate mass. All you're going to do is cover up mass with your finger, and now you can see that mass is equal to density times volume. They're together, so that's multiplication. Let's say you have to calculate volume, so cover up volume, and now you can see that volume is mass divided by density. So those are the three formulas that we do need to know for density calculations. So again, density for solids is grams per centimeters cubed. If it's a liquid or a gas, it's grams per liter or grams per milliliter. So mass is measured in grams. Volume is measured in centimeters cubed if it's a solid. It's measured in liters or milliliters if it's liquid. Okay, in this table, we can see some common substances and their densities. So here we have fluids and here we have solids. So for example, water, we already discussed water a little bit. Its density is 1 gram per milliliter. And then, for example, helium, it's 0.0002 grams per milliliter. Then we have some solids on this side. So for example, sugar is 1.59 grams per centimeters cubed. So much more dense than, for example, water. Nickel is 8.90 grams per centimeters cubed. So again, much more dense than, for example, water. And this table is in the textbook on page 52. Okay, so let's do this example. What shiny solid has a mass of 356 grams and a volume of 40 centimeters cubed? So here's our table. We need to figure out which shiny solid it is. All right, so for this example, what shiny solid has a mass of 356 grams? So we're told the mass, and it has a volume of 40 centimeters cubed. So 40 centimeters cubed. And we know our formula for density. Density is equal to mass over volume. All right, so let's figure this out. Our mass is 356 grams, and we're going to divide it by volume, which is 40 centimeters cubed. All right, so we're going to divide that, and when we divide it, just put it into your calculator, 356 divided by 40, that gives me 8.9 grams per centimeters cubed. All right, so now that we know the density, we can go to our density chart and match what we got to an item on our list. So if we go here, we can see that nickel has a density of 8.90 grams per centimeters cubed. That's exactly what we calculated. So therefore, our shiny solid is nickel. All right, so this just quickly showed the calculation again and what the item was. It was nickel.